In this lecture, we'll explore the concepts of data processing pipelines with chained generators, iterator chains, and learn about the itertools module and the various functions therein that we're going to be using as part of the hands-on sessions in this course. With respect to iterator chains, these chains are analogous to an assembly line where data passes through various stages of processing, one step at a time. This approach is particularly advantageous for handling large datasets as it processes data sequentially. As you'll remember from previous lectures, generators, a key component of iterator chains, are created using functions that yield values instead of returning them. And this feature allows generators to produce a series of outputs for each input, making them ideal for stream processing. In the hands-on coding session that will follow, we'll delve deeper into how this concept is applied in practical scenarios. Here's an example of what this can look like. We start off with a generator for reading data. This reads data from a source, and for each line in the source, it yields the line. Then we have another function for transformation called filter data that has two arguments, the data and a condition. For each item in the data source, if that condition is met, it then yields that item. Another function for processing called analyze data then accepts two arguments. One is the data, and the second, an analysis function. Then for each item in the data, this function yields a call to the analysis function with that item passed in as an argument. With these three functions in place, we can now combine these generators into a pipeline where the data source gets data from the read data function, the filtered data variable gets populated with the output from the filtered data function that accepts the data source and a lambda function defining the condition, and the analyzed data variable gets populated by the output from the analyzed data function. Finally, in the last step, in consuming the pipeline, for each result available in the analyzed data returned by the analyzed data function, we simply print the result. Let's now talk about some considerations and best practices. In terms of memory efficiency, iterators process elements one at a time, which minimizes our memory footprint. In terms of modularity, each part of the chain can be independently modified, tested, or reused. And in terms of readability and maintainability, breaking down the pipeline like this enhances the code readability and makes maintenance of the code considerably easier. However, this approach might not be suitable for every scenario. So, for instance, iterator chains are not inherently designed for, say, parallel processing. Additionally, for small datasets or simple transformations, perhaps a more direct approach might be more efficient than crafting an iterator chain. So please do keep these things in mind prior to going down the path of, yes, I certainly need an iterator chain to address this problem, or I don't. Let's now talk about using Python's itertools module. The itertools module in Python is a collection of tools for handling iterators. It provides a suite of fast, memory-efficient tools that are useful in creating complex and efficient data processing pipelines. When used in conjunction with the concepts of generator functions and iterator chains that we've covered so far, itertools can significantly enhance the capabilities and performance of your code-based data pipelines. The chain function from itertools is used to combine multiple iterables into a single continuous iterator. This is particularly useful when you have, say, several data sources that need to be processed in a unified manner. iSlice allows for slicing of iterators similar to slicing lists, but in an efficient way that doesn't require the iterator to be converted into a list first. The compress function filters one iterable based on the truthiness of the elements in a second iterable. This is akin to filtering data based on a set of criteria. The group by function groups items in an iterable based on a key function. It's incredibly useful for categorizing data before processing. Next, we have the cycle method for quite literally cycling through data. The cycle iterator returns elements from the input iterable repeatedly, and this is useful in cases where you need to cycle through a set of values. Then we have the product function. The product function generates the Cartesian product of input iterables. It's akin to a nested loop in terms of its functionality. And finally, we have the T function from itertools that duplicates an iterator, creating independent iterators from a single source. This is useful when you need to iterate over the same data in different ways simultaneously. Here's an example that combines several itertools functions into an iterator chain, and it's one that we'll be going through in a lot more detail in the hands-on coding session shortly. For now, we can take a look at this example to develop an intuition of what the chaining of functions actually looks like. Let's now head over to the hands-on coding session to see everything we've covered in action. See you shortly.